This is a third and final part of the notes for Algebra 3 with trigonometry, Unit 2 quadratic equations, Section 1.5 quadratic equations. So what we're doing is we talked about a quadratic equation. We talked about the different methods for solving. I gave examples on solving by factoring. I then talked about the square root property to lead into completing the square. I talked about perfect square trinomials to once again lead into completing the square. And then we did some completing the square. So those are on 2 previous videos. Now we're going to talk about using the quadratic formula. The quadratic formula is also very useful because it can be used to solve any quadratic equation. Some people would prefer that over other methods. Others don't enjoy it, but it's something that I do want to make sure that you know how to do. Up through Algebra 2, you were given the formula. After Algebra 2, you're not given the formula for quadratic formula. There's tons of great videos out there on how to memorize it. There's some wonderful songs. However you need to memorize it, you need to memorize the quadratic formula. So the quadratic formula is a special case where ax squared plus bx plus c equals 0. We had to set quadratic just like this when we were factoring. And there's specific steps. First, you write the equation in the general form or standard form. We identify the values for a, b, and c. We substitute the values for a, b, and c into the quadratic formula. I'm going to show you how to determine the value of the discriminant and reduce the radical and simplify the whole term. And then you're going to check your solution either in the original equation or by graphing. My first example is 5x squared minus 3x equals 2x. So I'm first going to rewrite this to 5x squared minus 2x minus 3 equals 0. I always try to keep the term in front of x squared positive. It's going to save you a lot of trouble later on. So my a is going to equal 5. My b is going to equal negative 2. And my c is going to equal negative 3. So when I plug everything into the formula, I've got negative b, so negative 2 plus or minus. And notice I'm using parentheses, so I don't make mistakes. B squared will be negative 2 squared minus 4 multiplied by a multiplied by c, all over 2 times 5. So my next step is to determine the value of discriminant. I want to figure out what this number is. So negative 2 is a positive 2, plus or minus. I would recommend doing this in your calculator, but I've got 4 minus a negative 60. So 4 plus 60, I think. Let me double check it, make sure I have it right. Oops. Negative 2, clear. Negative 2 squared minus 4 times a times c, 64. Okay, I did have it right. So this is a 64 over 10. This is a positive number. If this is a positive number, I can take the square root of this, and if I can take the square root of it, I'm going to end up with 2 real answers. So I'm going to have x equals 2 plus or minus 8 over 10. So I'd have 2 plus 8 over 10 and 2 minus 8 over 10. 2 plus 8 over, this is 10 over 10. I think I'm losing ink. So I have x equals 10 over 10 and x equals negative 6 over 10. So I'm going to have x equals 1 and x equals negative 3/5. And I would check it in my calculator. And actually, when I practiced this, I had a different answer, so I am going to go ahead and check it. So 5x squared minus 2x minus 3. I'm going to go to my graph, So 1 and -3/5. So this first one I'm going to find right here. It's between -1 on the left and 0 on the right. -0.6, that's -3/5. This one here looks like it's at 1, and I could check it the way I just checked it, but another way to check it is I can go to my table of values, and right there, x is equal to 1, y equals 0. That's exactly what I want. So I know those two answers are correct. My next equation, this is my last one, I'm going to rewrite it in form 3x squared minus 8x plus 7 equals 0. So my a is going to equal 3, b is equal to -8, and c equals 7. When I plug everything into the formula, negative b, so negative and -8 is going to be a positive 8, plus or minus -8 squared. This is where I make it a little bit easier on myself. I know -8 when it squares becomes positive, so I'm just going to go ahead and write 64 here. I've seen too many people put -8 without parentheses, and when they put it in the calculator they get a negative number and they don't understand what they've done wrong. So I know this is positive. I'm just going to do the square in my head and put that there. Minus 4 times a times c all over 2 times a. So now I've got 12 times 7 is 84. I'm going to have 64 minus 84, so it's going to be -20. So I'm going to have x equals 8 plus or minus the square root of -20 over 6. This is why we reviewed complex numbers before doing this section. This is going to be a complex number. 20 is 4 times 5, so I'm going to have plus or minus 4, not 4i. This is why I didn't want to use this pen, because I made mistakes. I'll white it out. The other pens I like, they're erasable. So 2i square root of 5 over 6. My 8, my 2, my 6 can all be reduced by a factor of 2. So I'm going to have x is equal to 4 plus or minus I square root of 5 over 3. This one has two complex numbers. It has imaginary. They're not real. It's because it's taken the square root of this -20. It doesn't mean that they don't exist. They're just not in the real coordinate plane. So if you have a negative number, once you do the radical here, you're going to have an I in your answer. So on a recap of Algebra 2, and I know this doesn't show up really, really well. Let's go ahead and zoom in a little bit. That's better. So for quadratic, the graph is y equals ax squared plus bx plus c. These are all just generic quadratics. If the discriminant, so that discriminant is this b squared minus 4ac, if that value is negative, like it was in our last problem, it's not crossing the x-axis. So the number of solutions, it doesn't have any x-intercepts, it doesn't have any roots, but it has two imaginary solutions, or you can call them complex solutions. If b squared minus 4ac is equal to 0, so if you work everything out and underneath the square root there isn't a value other than 0, you're only going to have one solution, and it would just be touching the x-axis. So there's one x-intercept, one root, it's called a double root, and it's a real solution. That means it actually physically touches the x-axis. You can graph it on the real coordinate plane. And the last one, if b squared minus 4ac is a positive number, like the first example I did, that means it's going to cross the x-axis in two places. So these two places where it crosses the x-axis are going to be the two x-intercepts. They're called two roots, and they're two real solutions. Later on, when we solve equations of different polynomials, we're going to come back to this, so this will be very important. And that's the last of this video.